Okay, welcome back. So at the top of your notes page, it should say multiply and divide whole numbers, estimate products of multi-digit whole numbers. All right, so let's go ahead and get to it. Okay, let's try to do some mental math, a little bit of review from our last lesson. Here I see 31 times 2. Well, I know anytime I do multiplying by 2, I'm going to double it, right? So go ahead and double 31 in your mind. Okay, and then I see a 0 behind the 31, and I see a 0 behind the 2 for the 20. So what do you get as your product of 310 times 20? Okay, you should get 6,200. We get 62, that doubling of 31, and then the 2 zeros behind it. Awesome, okay? Between which two 10,000s would 48,625 fit? Okay, so I'm going to look at the place value. Again, my ones, tens, hundreds, thousands. Here's my 10,000s right here. So between which two 10,000s would this number be between? Well, I know it's going to be between 4 because it starts with a 4, so between 40,000 and 50,000. Between 40,000 and 50,000. What is the midpoint, also known as the middle of 40,000 and 50,000? Well, that would be, the middle we know is 5, right? A 5 of any number, so that means I'd have 45,000. Okay, so would 48,625 fall above that midpoint or below that midpoint? Well, it would fall above the midpoint. So if I were to round 48,625 to the nearest 10,000, that means that that number would round to 50,000. It would round to 50,000. It would be much closer, again, that number is somewhere over here, it would be much closer to 50,000 than it is to 40,000. Okay, so that brings us to what we're doing. When we estimate, we're kind of rounding to help us make our math a lot easier, right? So today we will estimate the products of multi-digit whole numbers. So let's look at how many students we have in the class. Let's assume that we have 37 students in our class. It will depend on how many you have in yours. Do all the classes have exactly the same amount of students? No, they do not. Some classes have 37, some might even have 32. If you go in the primary grades, they have at most 27, so it's very different, right? There are 26 classes, but I'm not sure exactly how many students are in each class. What could I do to find the number of that is close to the actual number of students in our school? 26 classes. And I said some classes will have 37, some classes will have 27, 24 in them. So it might be good to find some middle ground there and go with 30 per class. Okay, what number could help me make this estimate easier for the number of students in each class? Again, I'm going to go with 30. I think that would be easier. It's in between the numbers there. For 26 classes, remember that's 26 classes meaning 26 groups of students. What could I round 26 classes to? Well, I would round 26 classes also to 30 because 26 is closer to 30 than it is to 20. So 26 groups, or we're going to now call it 30 groups for our estimation, 30 groups of 30. So that means we're going to multiply 30 times 30. Well, 30 times 30, I'm going to look for that basic math fact that I can do in my head that I have memorized. 3 times 3 gives me 9, and then I have those 2 zeros in my problem behind that basic math fact. So my estimation would be that we have 900 students. Around 900 students. Now, because my estimations got further and further away, my estimation could be pretty far away from the exact answer. When we were just adding and subtracting, those estimations were very, very close because we're using simpler numbers, we're using something that's not going to dramatically change as much. When we multiply, each number different is going to drastically change our answer, right? If I multiplied 1,235,000 by 30 versus by 31, my answer would really change a lot because that one group is a million of whatever I'm talking about, right? So multiplication can change our answers quite a bit. So that's why when we estimate, we want to get as close as possible to the exact numbers. Okay? Estimates can help people understand if our product, if our answers are reasonable. Do they make any sense mathematically? Okay? So when I look at a math problem and I solve it, normally we estimate, you can estimate before or after, but sometimes you estimate after just to check if your answer makes sense. But when I solve it and I'm way off base, do I have like several digits off? Then I might need to go back and double check my answer, right? Okay, so let's go ahead and get into our notebook. We have to estimate the product of 456 and 42. Okay, the nice thing is we're not actually finding the exact answer in this moment. We're just going to find the estimate. Well, guess what? We're going to use what we did yesterday and use that with our estimation. So how could I round the factors to estimate the product? How could I round the factors? So let's look at the number 42. Let's round the number 42 so that way we can come up with a good estimate. 42 is really close to 40, right? So I could estimate, round 42 to 40. What about 456? What would you like to estimate or round that to? Well, we could round that to 500 because it's closer to 500 than it is to 400. And then we'd have 500 times 40. Okay, can we do this math in our head? Well, I see my basic math back there. 5 times 4 gives me 20. And then I have those zeros behind it. 1, 2, 3. So my estimation would be 20,000. Now, 42 and 40, very close together. 456 and 500, well, there's some distance there, right? Because this is very close to being in the middle. So this estimation could be a little off. Could be a little off. Okay, again, we got that 20 times 1,000 getting 20,000. Now, sometimes it will help if here we rounded up to 500, right? But what if we rounded down? Let's say this was 40, and then we said, ooh, this is in the middle, so I'm going to round this to 400 instead. Well, if I did that estimation, 4 times 4, that gives me 16. And then I have 1, 2, 3 zeros behind that. So I'm coming up with a better estimation here. I know my answer, my exact answer, would need to be between 16,000 and 20,000. Because 456, that's pretty close to being in the middle of 400 and 500. So now I at least have a range. I know if it's between those two numbers, then it's probably an answer that makes some sense, is a reasonable answer. You're going to go ahead and estimate 4,560 times 42. Go ahead and pause the video. Alrighty, here we go. So I estimated 42 to be 40, and I estimated 4,560 to be 5,000. Take that basic math fact, put it right here. We get 5 times 4, which is 20. Right? 5 times 4, which is 20. Then we see 1,000 times 10 to give me 10,000. And if I multiply, excuse me, if I multiply these numbers, I have 1 0, and then I have 1, 2, 3, 4 zeros behind the 20. 1, 2, 3, 4 zeros. So my estimation here is 200,000. 200,000. Let's say you estimated this to be 4,000, then you would have an answer more like 160,000. It's an estimation, so it's not going to be precise. Again, this is in between 4,000 and 5,000, so I would probably do both of them so that way you could come up with a good range to know if your answer makes sense or not. Okay. Let's estimate 1,320 times 88. We're going to round these factors so that we can estimate the product. What could I round these factors to be? What would you like to round 88 to be? Well, I could round 88 to be 90, so that's what I chose to do. 1,320, I could round it to be 1,300, 1,300, or I could even round it all the way to the thousands place and round it to 1,000. Either way, up to you. Okay, I'm going to show you both ways. Which do you think would be closer to the exact answer? Well, this one on the left here, this 1,300, would be much closer to the exact answer because it's much closer to my original number. This one's a little bit further away, so it's not going to be as close. Okay? Here, I'm seeing my basic math fact that I can pull out. I have my 13 and I have my 9. And then I have my 100 and my 10, my 100 and my 10. 13 times 9, let's see, that's going to give you 117. If you didn't know it, you could always use that standard algorithm to find out that part of it. 9 times 3 giving me 27. 9 times 1 is 9 plus 2 is 11. So there's that 117. You could have also thought, okay, 9 times 12 is 108, and 108 plus another group of 9 would be 117. 100 times 10 gives us 1,000. So when I multiply these, my estimation would be 117,000. Okay, this one, of course, a lot easier to do in our heads, a little less steps to work through. We would do 1 times 9, find that basic math fact, and then look at the zeros behind it. 1 times 9 is 9. 1,000 times 10 gives me 10,000, and 9 times 10,000 is 90,000. Notice how, just by my slight difference in rounding, my estimation gets a lot different. Right? But we know that because this number was closer to the original factor, that my estimated product, is much closer to the actual product if I were to solve these numbers. Okay? Alrighty. Okay, which estimation gets me closer to the exact answer? Again, that would be this one because it's closer to the original factor. Okay, are both ways of rounding acceptable to do my estimation? Yes. The whole point of estimating is so that it's easy for you. It's so that you can check if your answer makes mathematical sense, if it's reasonable. So either way is correct because estimation truly, it's best if we can do it in our heads. Right? Or we can jot some things down, but it should be a quick mathematical thing for you to do. When you estimate in real life, are you going to write all this down? No. I'm having you write it down so you understand the thought process, why we can use the rule of putting the zeros behind the number and so forth, just so you understand and see it. Okay? Alrighty. Before you estimate this product, compare this problem to the last problem that we did as a class. What do you notice is different? Okay, Well, I'm comparing this one to the last one that we did as a class, and I see I'm using some bigger numbers here, much bigger, right? Okay, go ahead and estimate these numbers. Go ahead and estimate. Okay, so again, you could estimate in a couple of different ways, not even necessarily these two. Maybe you chose to estimate a little differently. I used 900 in place of my 888. Okay, I used 13,000 in place of the 13,205. And when I multiplied 13 and 9, I got that 117, and then I have the same amount of zeros that are behind each of my factors behind that, right? Or I could have taken 880 and rounded all the way up to 1,000 if I was rounding to the nearest 1,000, and 13,205 if I was rounding to the nearest 10,000 would round to 10,000, right? So this gives me 10 million as opposed to 11,700,000. Well, now I'm 1,700,000 off, right, from my two estimations. This one is closer to the actual answer because it's closer to the numbers that were in my original problem, okay? But both are acceptable ways to estimate. What is the benefit to estimating products? It makes it possible to do mental math, to make an educated guess, or to check your work. Does it matter if we round one or all of the factors? It does not matter how many numbers you round. Again, the point is just to make it easy for yourself. If our rounding is further away from the factors, what would that mean for our product? That means if our rounding is further away, our estimation, that product, is going to be further away from the exact answer. Okay? The more we round, the further away we get from the factors, the further our product would be from the exact answer. Okay, so go ahead, let's estimate the product here. 52 and 27. Ooh, 52, that's close to 50. 27, ooh, that's close to 30. Ooh, I learned how to do this yesterday in our math class. Put 2 zeros behind it. Ooh, 1,500 is a good estimation for these numbers. All right, guys, thank you so much for joining us today.